Hello everybody, and welcome to the beginning of section 2.1. This is the start of a new chapter for us. Okay, and we're looking at page 37 in the workbook, and up to this point in the course we've been talking a lot about derivatives. We are going to continue talking about derivatives, the idea of the rate of change of a function, but our perspective changes a little bit in chapter 2. So in this chapter we're going to be focusing on finding more efficient ways of finding the derivative if our function is given to us in the form of a formula. Okay, let me show you what I mean. So I'm going to flip pages on you here for a minute. And I'd like to look at a problem where they give us a function, f of x equals x cubed, and ask us to find the derivative. How would we do this problem? Okay, well, up to this point in the course, we really have only one way to calculate a derivative like this, and that's to take a limit. Okay, so if we wrote this out, the derivative would be the limit as h goes to 0 of f of x plus h minus f of x over h. That's our definition of the derivative. And if you think about what's involved there, next step would be to ask ourselves, what is f of x plus h equal to? Well, algebraically, that's asking us to take x plus h and substitute it in for x in our formula. Okay, so the limit that we would need to calculate looks like this. Okay, and then notice what would happen next here. X plus h cubed, by definition, is x plus h times itself 3 times. And if we wanted to continue with this calculation, we would have quite a bit of algebra to do. Take a look at this. Taking x plus h times itself 3 times, that's something that we could do, but it would take a lot of algebra to do that. Okay, so the point here is, could we find an easier, more efficient way of doing this instead of having to continue with this calculation? Okay, that's kind of the goal of this section. All right, so let's put that on hold for a minute and back up. Okay, back to page 37 here. And before we can really get into a discussion about derivative formulas, it's convenient to have some alternate notations for the derivative. Okay? So let's assume that we've got a function in the form y equals f of x. We're going to make a list of various ways that we could write down the derivative. Okay, so the first thing on our list, this notation you've already seen. Okay, so we've already used the notation f prime of x or just f prime to represent the derivative, and we'll keep doing that. You'll keep seeing that notation. We're going to add a couple of alternate ways to write the derivative to our list, though. For example, we could just write y prime. That's a little bit of a shorter way of writing down the derivative. Okay, and then third way, this notation is probably going to be new. I don't know that we've seen this in this course so far. dy dx. Okay, in words, when you see that, you can think of it this way: the derivative of y with respect to x. That also represents the derivative. It's a way of emphasizing that y is the output variable and x is the input variable. Okay, and then finally we'll add one more thing to this list. We could write d dx of f of x. Okay, in words, the derivative with respect to x of the function f of x. Okay, now this is a lot of notation that you're looking at, and I want to emphasize all of these formulas, 1 through 4 that we see here, they all represent the same thing. They're just different ways of writing down the derivative, and depending on what situation we're in, we might find that one notational way of representing it is more convenient than another. Okay, and in the next video, we'll get started talking about shortcut formulas.